So we have seen the architecture of SD-WAN earlier. We saw various components and protocols in SD-WAN. Let's quickly have a recap. Better to have a recap before we get into something new. We got an orchestration plane, right? Orchestration plane. What it is? Where do we find orchestration plane? Which member of SD-WAN is an orchestration plane? vBond. Right? This is the orchestrator and also the control and management plane. Why we call it as orchestrator? This is the one to which the devices get first authenticated. This is the first authentication point. We learned these points, right? Okay, this is the authentication point. Right, once edges are authenticated, they are given with the IDs of vSmart and vManage. Who provides? vBond provides. It distributes the list of vSmarts. vBond only provides the information about the vSmarts. We may have many vSmarts. We may sometimes have many vManage. So the information about the vSmart and vManage, vSmarts and vManage are given by distributed by this orchestrator called vBond. Not only that, this is also responsible for NATing. If there is a need for NATing, then the orchestrator has to take care of it. For which this orchestrator need to be in a public, meaning this vBond needs a public IP address. Wherein you can do one-to-one NATing if we are going to have private. So NAT reversal is taken care, authentication is taken care. That's why we call this as an orchestrator. This is the very first point where the members gets enrolled. Not only enrolling, vBond provides the list of vSmart and vManage devices to every vEdge routers that gets authenticated. Right. So the next is what we learned is vManage. So what we just saw is orchestration plane. Next is the management plane. Where we have vManage. This is actually a software. This provides the centralized network management system. It's a software. So through vManage, we get a single pane of glass. We do all basic configuration. So in networking, we used to use this language, Day0 to Day3 job. All the Day0 to Day0. Day 0 to day 2, that is what, sorry, it's not one. Day 0 to day 2 operations. Day 0 to day 2 operations are carried out in this vmanage, meaning every policies, templates, everything. So the software also provides us the role-based ACL, access control, and centralized provisioning. You know what is role-based access control? Depending on the role, the user will have different level of privilege in controlling this SD-WAN, SD-WAN architecture, SD-WAN topology. So it is the vmanage, the one which provides the role-based access control. Let me write down. Role-based access control and centralized provisioning. Not only that, this is the one through which we install certificate, template. When I say template, what I mean is the configuration for the vEdge devices. So we just put all those necessary configurations for the vEdge devices. I can also, here we call it as actually template, not config. So let me use the word template. Also, it helps to install certificates. So we install the certificate template configuration for edge device. When a new edge device comes to vBond, vBond is going to verify with a certificate. How vBond knows the certificate? vManage provides the certificate. For that, we need to install the certificate. So we install certificate to vManage. We put all the necessary configurations in templates, and whenever it is needed, it will be utilized. It is not going to be immediately used. Certificates will be used when a new vEdge device comes. Likewise, the templates that you assign, you configure, they may not be used immediately, but as the devices gets attached, those templates are going to be used on demand. So for that, the edge device needs to come online. So now if you see, all the edge device needs to know the vManage. So it is good to locate this in some centralized location. Keep it in some centralized location, like we used to have data center in our classical network. Where do we have data center in our network? Middle, no? Have you seen that in a topology? I'm not talking about SD-WAN. If you take simple network, usually data centers are center of the network. Like you keep a data center for the center of the network topology, try to locate this vManage in the center location for the rest of the network. There are some interfaces like REST, API, Netconf. We'll deal about those things later. To an extent, we'll see. So those things are also available in vManage. It's just an interface through which you can control the SD-WAN REST API. And Netconf. So these two are the interface through which you can also control SD-WAN. So those interfaces are also available in this I Manage. See, it is like we have no GUI, GUI, CLI mode. We have, right? Likewise. See, CLI, Cisco CLI. But this REST and Netconf are independent, vendor independent. You can use it to control any device. Yeah, kind of console. It's a kind of console through which you can configure SD-WAN. So those who know those REST API, Netconf commands, they can use those consoles. Like when we have Juniper command, you can go and configure on Juniper device, right? Cisco command, you can configure on Cisco device. If you want to configure on both Cisco and Juniper, but I don't know about anything about Cisco commands. I know only Juniper commands. If you know REST or Netconf, you can to an extent, not all features may be available. To an extent, you can configure any vendor device. It's an interface. It will translate into Cisco commands for you. If you don't know Cisco commands, it will translate it for you. Instead of saying like that, what I should say is, see, if you configure through Cisco commands, they are actually going to be converted into XML file. XML. When you configure through Netconf, it directly goes into XML. There is no need to translate into Cisco CLI. Let me repeat what I'm trying to say. When you configure through CLI, do you think everything is CLI at the background? No. There is some Linux shell. They're translated, correct? The Cisco routers, just take normal Cisco router, not SD-WAN, simply the simple router. They're actually Linux based. When I type show IP interface brief, it is showing the interface brief, but behind the screen, it is converted into Linux command. This REST and the Netconf is like directly it will go and talk to Linux. So any vendor device, they can understand the language of REST and Netconf. It is like, vendor independent interface platform, vendor independent console. So those things, you need to learn separately. If you know those things, you also have an option to use them via I Manage. See, why do we have I Manage? To configure. But if you say no, I Manage, I'm not comfortable. I know REST API. I know Netconf. Can I manage SD-WAN through Netconf? Yes, there is an option for you. You don't need to stick on to Cisco's I Manage GUI. You don't need to use the GUI if you're not comfortable. If you're comfortable only with Netconf, you can go with Netconf. So here they are trying to give you an industry standard option to configure SD-WAN. You understand? Instead of Cisco's dependent GUI, Cisco's GUI, they give a open source kind of command line, open source kind of console. where many may be comfortable. In coming days, many will be comfortable with what we are seeing here, REST and Netconf. Because if you know REST and Netconf, not only Cisco SD-WAN, you can also go and configure any SD-WAN because everyone provides this option for you, REST and Netconf. In the SD-WAN, everyone has got this option. Right. So that's about the management plane. So you may have one vBond or many vBond. You may have one or more vManage. It can be single or multi-tenant capable. Now you can have vSmart, which is our next topic in the revision, vSmart. vSmart and vManage can be in the same place. We can run both the device, both the software actually, vSmart and vManage or software. So if needed, you can keep it in the same place, somewhere centralized. You can keep it in one single location, vSmart and vManage. So next is that vSmart. vSmart is a control plane. vSmart. Yep, it's the main portion of control plane. This helps to do fabric discovery. Discover the SD-WAN fabric. You understand what is fabric? SD-WAN topology. SD-WAN is not a physical topology, no? It's a virtual topology. There is a physical topology underlay, on top of which using OMP, you learned those things in the previous class. OMP, Overlay Management Protocol, using which you form a virtual topology, which is totally independent of physical topology. So that virtual topology, the overlay topology, is what we call as SD-WAN fabric. vSmart helps to discover the SD-WAN fabric. Not only that, then sends the control plane information between vEdge. Sends the control plane information. See, our topic is what? Routing, correct? That's why I'm revising this. Control plane is what? It's routing. So who distributes the control plane information? It is the vSmart. To whom it sends? It sends to vEdges. I want to make one thing very clear here. You see, vSmart, vEdges. All the vEdges will be reporting to vSmart, using which a control plane is built based on the vManage configuration. So there is no direct communication between vEdges. Understand, that is very important. OMP works between vEdge and vSmart. Repeating again, OMP, Overlay Management Protocol, they work only between vEdge and vSmart, not between vEdges. It is the vSmart, the one which is going to distribute the control plane information. So what is the advantage? The control plane complexity is reduced. See, in OSPF, we have DR, BDR. Why all BDRs are not, why all DR others are not allowed to communicate? That will create control plane complexity. So all the other routers will report to designated router. Likewise, using OMP, all the edge devices communicate to vSmart. So vSmart controller forms DTLS connection to the vEdge devices, and it transmits the encrypted routing information that are relevant to the vEdge devices. Did you understand what I said now? So tell me, what is the protocol that is used to send the routing information? Just I said DTLS. Right, vSmart controllers forms DTLS connection. That's the type of connection it uses. Dynamic Transport Layer connection, TLS connection. It's highly secured. It is encryption actually. So it sends all the routing information in an encrypted format. Encrypted routing information to the edge devices, to the relevant edge devices. So we have just spoken about vSmart, vManage, vBoard. But this is not over. The OMP is the routing protocol in vSmart. See, DTLS is an encryption protocol. That is how we transport the routing information. It is carrying the routing information in an encrypted format to the edge device. But edge device and vSmart, they communicate using OMP. OMP is the routing protocol. OMP is the routing protocol. You can also compare OMP like BGP. Right, so as I said earlier, the VHS, they don't communicate each other through OMP only. The informations are shared, the discovery of the VHS by the vSmart happens, it is through OMP. After that, the control plane is built based on the configurations that we have put in vManage, and they get distributed in an encrypted format to all the edge device. So routing information on the edge device sends to the vSmart device and sent to the other vSmart controllers and onwards to the vEdge devices as per the configuration, as per the necessary policy. I don't know how much you understood what I said lastly. Can you try to put in your own word and explain me all these points about vSmart so that I'll understand how much you got it. Mm, mm, mm. Correct. Mm. DTLS is going to transport the routing information in an encrypted format um, to the edge devices. But how vSmart knows about the routing information of each edge device? Through OMP. See, let's assume you are one edge device. You are going to advertise to vSmart saying, I have these many networks. In my LAN, I have these many networks. You can come to me if you want. You use OMP to tell to vSmart. Likewise, I also advertise my LAN information to the vSmart. Now, vSmart knows about your LAN information and my LAN information. Now, according to the vManage configuration, the required configuration from your routing table will come to me and my routing table will go to you according to the policy. Hmm. Hmm. Yes. So sometimes vManage may not allow you and me to communicate. In that situation, my routing table will not be given to you. Even though vSmart knows about your route, your destination, my destination, the policy don't allow, so vSmart won't form a control plane between you and me. When you ping, you cannot reach me. When I ping, I cannot reach you. But when someone pings you, they will reach you because as per the policy, they can talk to you. So the control plane is built as per the policy. It is not simply all routing table, okay, fine. Like a DR, it collects all the information from the other routers and give it to all other routers. It takes from other router A and gives to B, C, D, and E. No, not like that. Before sending to B, C, D, and E, it will check whether I'm allowed to give this. Whether D, C, and E are allowed to know about A. Yeah. So that is what I meant, when I say requirement, as per the requirement. As per the requirement, the informations are going to be distributed. So that's about the vSmart. Next is the last component is, okay, one more thing is vSmart has it needs to authenticate any connection from new VH device. So this vSmart will also authenticate the edge device. vBond, correct. After that, vBond gives the information about the vSmart and the vManage. Now, vSmart has to authenticate any connection from new edge device, new vEdge device, so that it manages that as well. So, understand this one very well. What is it? vBond authentication is correct, but vSmart also needs to make sure. Yeah, you can say like that, yes. So vSmart has to authenticate any connection from new edge devices so that the vSmart will know that I can manage the device. I can manage the edge device. Right. Finally, we have vEdge device itself. vEdge, it is also called a CH. Yeah, definitely. The certificates are also known to vSmart. Correct. After that, only they are going to give and take the informations. Otherwise, they don't take. So next is the V edge or VC edges. C edges or Cisco edges. This is the tip of the network where the data plane is residing. Data plane. Yeah. So all the control policies comes from the vSmart, and that defines the data plane on the edge device. And also this V edges or C edges, they support zero touch deployment. I'm just trying to revise what we learned earlier. Zero touch deployment. Not only that, the port performance statistics, it can provide the statistics of how much bandwidth available and so on. Port performance statistics. Yeah, so we're going to go detail into this port performance statistics later. So this is what we have learned in the past. Now let us get into the routing side. To understand the routing part more, we need to understand the protocols and topologies. We have two different type of networks here. Before that, let us talk about the protocol options. SD-WAN, you can have a static route. But for a large scale, it won't be helping us. Same like, in your normal production, do we have static route? Yes, we have. Where? On the edge device, we have a default route to an ISP. Yes. In the real world, you can see that default route to ISP network. Sometimes some static routes. But yeah, but for large scale, we depend on dynamic routing protocol. Same likewise, even in SD-WAN, we can use static route. We can use OSPF. Now, when I talk about OSPF is not only for the SD-WAN overlay. You can also use it for transport, both for service and for transport. You understand what I mean by service and transport? See, service is the one which SD-WAN provides, means those tunnels, those VPNs. But to have that VPN, there is an underlay, no? Underlay. Who is underlay here? ISP. Who is helping you to provide a virtual connection between the sites? ISPs. They are the transport. See, in the transport, you may have OSPF. On the VPN also, you may have OSPF. So when I say VPN, I mean service. When I say service, I mean the SD-WAN tunnels, SD-WAN VPNs. We'll talk about the VPN in some time, in a few minutes. So we have service and transport. Transport is basically underlay. Service is the overlay. You can see OSPF in both the places because it's the widely used service provider protocol. And also we will use BGP. BGP can also be used as the service protocol as well as the transport protocol if you have MPLS layer 3 VPN. Again, as I said, it depends on your network. Whether to use BGP or not, it depends on your network. Correct, but it has to give it to vSmart, no? Every edge device needs to provide the route information to the vSmart. Correct. OMP is used, that is true. OMP is used as a protocol in between, but once the virtual circuit is formed, established, for the service to find the shortest path, OSPF is also going to be used on top. See, OSPF can work end to end. Exactly, not OMP. See, you are coming near to very closer to the understanding. You see, OMP is not going to be end to end. OMP is only between the vSmart and the vEdge, correct? Now, after giving my route to you and your route to me, in the routing table, you don't see next hop as vSmart. You see me as a next hop. Who is pointing towards me as a next hop? It is OSPF. Just to establish the control plane, only vSmart will come. vSmart will not come in between our communication. For me, you are my next hop. For you, I am your next hop. Routing protocol is always a routing protocol. No way. It provides the control plane finish. It says, hey, this is the policy. This guy can talk to that guy. Those guys should not talk to these guys. No, those policies. And it will discover the entire fabric. Accordingly, it builds the control plane and pushes to the necessary vEdge devices as per the requirement. Finish. That's all the vSmart's job. And now OSPF takes control. And so OSPF is also not controlling. It provides the shortest path which the vSmart has prescribed. Even the vSmart is using that OSPF to provide you that information. It collects the OSPF link state advertisement information from your router using OMP and also from the other edge OMP, compares it, and then provides the control plane. Have you done DMVPN?
Yes, sir.
Now, if you have done DMVPN, what is the role of Nhrp? It is only for the discovery. It is only for the location of the spokes. One spokes will know about the other spokes through Nhrp. Then NHS and Nhrp, which is there on the hub router, learns one spokes and provides the information about that spokes to the other one. But are we stopping with that Nhrp? We also run a routing protocol, right, over the tunnel interface? Exactly the same thing here. That Nhrp is here OMP. And that EIGRP on the tunnel that you created on DMVPN is OSPF here. In future, even EIGRP will also come into picture. So far, no EIGRP in SD-WAN. But I have found that C-series iOS XC router, which supports SD-WAN, does support EIGRP even today. So EIGRP is also one of the routing protocol, but not on every device. Some iOS XC C-Edge devices. But the main three means of routing are static route, OSPF, BGP. Only these three. Now, so OSPF is a standard-based IGB protocol. So it can be used for both transport as well as the user traffic. User network is nothing but service. User network is service traffic. Transport is the core ISP, the MPLS ISP network. They also may run over OSPF. Right, so three things, but static, you know very well, they are not scalable. Now, let's talk about this one. Like, network is of two types: underlay network, overlay network. Underlay network and overlay network. What is underlay network? Then, yeah, the network that makes the SD-WAN to work. The network that provides the virtualized, or the one that provides the underlay network. Simple, the one which provides the environment for the virtual structure to come up, like a legacy network. So in that legacy network, you may have a static route or BGP or MPLS. Can be anything. Underlay can be anything. Overlay is a SD-WAN piece. Underlay is like on classical network. So two type of network, underlay and overlay. Underlay is simple, normal networking with MPLS, without MPLS, with a BGP, without BGP, static route, OSP, anything. Whereas overlay is the network provided by SD-WAN. It's a virtual network that links the site-to-site data center to the headquarters using OMP. It's only the OMP protocol that helps to connect to the sites. After that only comes the OSPF.
Sir, as per now, what do you think is how the industry is going to want to use SD-WAN? Why? Because we can find all networks. What do you find
See, I'll tell you. The SD-WAN is going to be there for a while, and then something new will come again. See, so we were talking about these routing protocols. Now, I was also saying that there are two types of networks, the underlay and the overlay. The underlay is like this. The underlay is, this is you in India, and this is me in London, and there is a data center, let's say in Australia, how can Australia come in between London and India? So in Israel. Now, to provide reachability, we have an MPLS connection. Now, I have a BGP connection here. Sorry, you have a BGP connection here. And I'm having OSPF. And Israel have got, let's say, no, ISA is not an option. We saw three, right? Static, BGP,
Yes.
OSPF towards the service provider I'm talking about. I'm not saying inside the service provider. Inside the service provider, there will be ISP. This is towards the ISP to provide route. Yeah, you can also use ISS, but yeah, you can also use ISS because it's an underlay, not a problem. Let's say Israel wants to have static. Now, for redundancy, we have internet. So, internet, I use static route. Sorry, you use static route. I use BGP, and Israel uses BGP. So, this is underlay. Now, SD-WAN is overlay. It uses this underlay. It uses this underlay to provide you the overlay. Overlay is not based on the MPLS or IP. See, overlay SD-WAN will not care about whether I'm going through MPLS or I'm going through internal internet. It will simply focus on TLOCs. The TLOC, transport locator. That's what I was saying, like locator identifier, like Lisp, TLOC. And this TLOC information is provided by whom? By OMP. You see how they are connected. So the physical links are abstracted. It is only the TLOC based on which the traffic is going to be moved. So there is going to be a virtual connection between this and this. This is the overlay. But to provide this overlay, you got MPLS and internet. You got internet and MPLS. So earlier we used to bind everything to BGP or MPLS or IP. Here we are not going to bind anything to IP or MPLS. They're all abstracted. It is only going to be TLOC. Transport locator. We'll go deep into this in our following class, transport locator. So this overlay network, which is also known as intersite link using OMP over the transport network, this is the one which is going to use a tunnel ID called VPN0. This is reserved for providing you this virtual overlay. How this overlay is built? OMP and the transport locator TLOC. Using TLOC, the tunnel endpoints are identified. To bring this overlay, VPN0 is what used. OMP will use VPN0. Please understand. Our traffic will not go inside VPN0. It's only the OMP, the management traffic goes through the VPN 0 in order to provide you this overlay network. Yep. So intersite link uses OMP to transport OMP. It uses VPN 0. You need to understand. We have OMP routes, we have user routes. OMP route is via VPN 0. There is also another VPN called VPN number 512. This is also a reserved number. This is for management. The out-of-band network that allows the vSmart, the vManage to make changes to the configuration. Did you understand what I said? See, for the vSmart and for the vManage, to make the changes, they communicate over the VPN called VPN 512. To bring the VPN tunnel between the sites, OMP uses VPN 0. The rest of the VPN, like VPN 1 to 511 and 513 onwards, those are used for customer traffic. Say customer may have a traffic for some LAN networks, for firewall security, for IPS services, for some service routes like voice traffic, video traffic, IDS, IPS. So to differentiate and put them into different traffic, tunnels, the other numbers from 1 to 511 and from 513 onwards, they're all for user traffics. So OMP uses VPN 0, using which it provides the transport locator identification and so on to help communicate between the sites. They need to know the overlay tunnel for which the OMP informations are shared using VPN 0. And whenever you do some changes in the vManage, it needs to impact in the path. For those management traffics, 512 is reserved. Only those management traffic will go through that 512. OMP is not between vSmart. OMP is between vManage and it is between vEdge and vSmart. And 512 is between vSmart and vManage for the management purpose. And all the rest of the numbers, except these two, 0 and 512, they're all used for user traffics. So user routes 1 to 511 and 513 onwards. VPN between vEdge and vSmart. Between vEdge and vSmart. VPN between vEdge and vSmart. The overlay management protocol between vEdge and vSmart, it is also 512. So not only this 512 is between the vSmart and vManage, it is also between the vEdges, but only for the management informations, not for the control plane. Say control plane impacts the management, that is true, but if there is something directly need to be returned to the vEdge, the vManage will talk to directly to vEdge. See, vSmart and vManage, it is 512, but sometime There are some configurations that are global level, which vManage itself will directly write it into vEdge. In that situation, VPN 512 is used. In short, VPN 512 is for the management. VPN 0 is for bringing up the overlay using the underlay. So VPN numbers are important. VPN 0 is working on underlay to provide you the overlay, like transport locator, OMP information using VPN 0. 512 is for the management between the vSmart and the vManage. Also with vEdge. And VLAN 1 to 511 and 513 onwards, they are user routes overlay. Right, so we have to now focus on OMP more. Actually, OMP routes are also called as V routes, virtual routes. See, for overlay, there is a different route. For underlay, there is a different route. We just saw it, right? We can have two OSPF, one for overlay. So those called as V routes. We have virtual routes, V routes, we have TLOG, transport locator, we got service routes for the user traffic. It is all taken care by OMP. See, OMP does not run between the V edges. They only connect to V edge to the vSmart. That's it. OMP routes are known as V routes. Again, these are only between the V edge and vSmart. So these are the routes that carry the subnet information like LAN prefix information from one site so that through vSmart they can be learned through other site. And the LAN networks are advertised over the WAN network. So you may have a static route to advertise, or you may redistribute, or you may use BGP or OSPF to do this. And then they need TLOG address for the forwarding. I think I have to go into detail in tomorrow's class. Let's talk about TLOG from tomorrow. I think whatever I have spoken so far, you understood. I do not want to get into TLOG right now. You need more time for that. So what we have learned today is a quick review of what we have learned in the past, and especially what we have learned here is the protocols. EAGRP only on XE series. Static OSPF BGP is allowed. We have VPNs, we have underlay network, overlay network, OMP, TLOGs. Right, so tomorrow we will focus more on OMP, which will also include TLOG. Yeah, we'll stop here.